Ivan's based in Moscow State University. Over to you, Ivan. Thank you.
All right, thank you. Hello, I'm Ivan Molodetskikh. I will present our work on quality assessment of 1,000 VR180 videos. So as you may know from the previous presentation, our group works on stereo quality assessment metrics. And with the recent spike in VR180 video format popularity, we have adapted most of those metrics for VR180, and we evaluated 1,000 public movies using them. So in this presentation, I will show some overall metric charts and trends and examples of artifacts that we have found. To adapt the stereoscopic metrics to VR180, so what we do is first we remap all VR180 video frames into a cubic projection, and then we take just the front face of the cube map, because first of all it contains the most information about the frame, and it also contains the least amount of distortion, and it doesn't have the black borders either. So this makes it ideal for stereoscopic metric application. All of the 1,000 videos we have collected from YouTube. To reduce bias in our video collection, we made 36 search queries in total. That is 26 English letters and 10 digits, one by one. Then we set the video filter to VR180 format, and we took videos from the first 5 to 10 pages along with their statistics. On the bottom, you can see two charts with statistics of the videos that we collected. On the left, it is the distribution by YouTube view count. So the x-axis shows view count on a logarithmic scale. And this shows that most of our videos lie somewhere between 10,000 and 100,000 views on YouTube. And on the right, we have a distribution videos by duration in seconds. Once again, the x-axis is logarithmic, and most of our videos are 10 to 20 minutes long on average. So first, let's look at the depth budget chart. So on this chart, on the x-axis, you can see the release date, or in our case, the video upload date. And on the y-axis, depicted is positive and negative parallax. So each of those lines is a single video, and the bottom point of the line is its highest positive parallax, and the topmost point of the line is the video's lowest negative parallax. So the longer the line is, the higher the depth range of the video is. And there are also two trend lines for positive and for negative parallax, which kind of shows the average depth budget. And what we can see from this chart is that there are both videos which have really small lines, which mean they have a really small depth budget. They are almost completely flat. And there are videos which have very long lines, which means they have an enormous depth budget. So say if you are watching random videos on YouTube or in your VR headset, one video will be really flat, and then the next video will have an enormous depth range, and it's likely that you will have some problems watching it in your VR headset. You might feel some discomfort. And it doesn't converge either. So with time, there is no convergence. So the video are kind of all over the place still. And this chart presents similar data, but now with a breakdown by percentage of scenes. So on the x-axis, we have all 1,000 videos. So each of those little columns is a video. And it shows the percentage of scenes in this video. Red means the scene has a small depth budget. Now yellow means it has, well, an average depth budget. Green means it has a good depth budget. And this red on the right means a very large depth budget. So we can see that there is a pack of videos on which most of the scenes are pretty flat. But overall, actually, videos are mostly fine. And on the right, there is a little bit of videos on which many scenes have an enormous depth budget. So even though on this chart it looks like it's kind of a mess, the videos are all over the place, actually on average the videos seem to be more or less fine and leaning towards the flatter range. So these are some examples of high negative disparity. So in these cases, there are objects very close to the camera. For example, this woman's reaching with her hand towards the camera, and this creates a very big negative parallax. And in this case, there are hands and other objects right in front of the camera as well. And those examples show both extreme positive and negative parallax. So once again, objects really close to the camera, and there is sky in the distance with a high positive parallax. And actually, note on these examples, we actually have some vertical shift as well between the views. So you can see on this text here, it shifts vertically between the two views. And on this person here as well, there is a huge vertical shift. And let's move to the vertical parallax chart then. On these charts, on the x-axis, once again, we have all 1,000 films. And on the y-axis, we have vertical parallax in field of view degrees. So they are sorted from the lowest, so no vertical parallax, to the highest, so the most severe instance of vertical parallax. And you can see that most videos are actually above the metric precision threshold. So most videos have some sort of vertical parallax. And this situation is actually worse than for 3D movies we have found. This chart has vertical parallax charted against the view count. So on the x-axis, we have the video view count from YouTube, once again in logarithmic scale. Each individual blue dot is one video. And we have some trend lines. So the top line shows the trend of the 33rd percentile for vertical parallax, and the bottom one shows the 66th percentile trend. So this is kind of the top 1/3, the best 1/3, and this is the worst 1/3 in the vertical parallax. And if we look at those trends, well, there is a big fall off to the left, but that's likely because we have very few videos with such a small view count. Well, this is a logarithmic scale. So, after that, the trends just even out. So there is no correlation between popularity as measured in views and its vertical parallax value. Next, let's look at vertical parallax versus upload date. In this case, once again, we have our upload date on the x-axis. And if anything, the trend lines show that videos uploaded earlier actually had less vertical parallax on average than videos uploaded later. And finally, we have a graph against the video duration, once again in seconds in logarithmic scale. And the trend lines are almost flat, which means that both long and short videos have the same vertical parallax on average. And these dots, they depict the average vertical parallax across the whole video. So here are two examples. The yellow square is zoomed in, so you can see it better, that the objects are moving up and down. Next, we move to scale mismatch. This is when in one of the frames the objects are bigger than the same objects in another view. And once again, we see the same structure with most of videos actually having some discernible scale mismatch. And if we chart it against the view count, then once again there is no clear trend. Well, the trend goes upwards a little bit, but then it goes back down. So even the most popular videos on average have the same scale mismatch as some less popular videos as measured by the view count on YouTube. Next, versus release date, we'll see a similar trend structure as with vertical parallax. Earlier videos have slightly better scale mismatch metric results, and later videos have slightly worse scale mismatch. So the situation only worsened over time. And versus duration, well, now there is a very slight upwards trend, so maybe longer videos have a little less scale mismatch on average. But still, it's not like a very stark trend. So here is an example. On the left, you can see that the person becomes slightly larger on one of the views. And on the right, well, the whole frame is distorted really, but especially on this rock, you can see how much its scale changes. So these are some representative examples. And these are like pretty popular videos as well. So this one is 200,000 views. This one is 28,000. not like one-off videos on very small channels. Next, rotation mismatch, when one of the frames, one of the views is rotated compared to the other. Similar situation here. Most of the videos do show some rotation mismatch above the metric precision threshold. When we chart it against the view count, once again, no clear trends, not like popular videos have less rotation mismatch or something. No, on average, all videos have about the same rotation mismatch. Versus release date, well, now at least we don't see worsening over time, but still it's not the videos are not improving in this aspect. And versus duration, once again, the lines are pretty straight, no trend, no correlation. Here are two examples of the rotation mismatch that we have found. You can see that the whole frame rotates a little bit between the views. Now, for color mismatch, this is when the colors are slightly different between the two views. For example, it can occur due to lens flares. And here the situation is actually a little better than with the previous metrics. It's just a little bit above the metric precision threshold for most videos, but there are still some bad videos in this regard as well. Charted against the view count, we see the same fall-off to the left, which is likely caused by a few videos with such a small view count. And overall, not really any clear trends towards improvement with popularity. Now, with release date, the color mismatch actually did improve. So in 2017, videos had worse metric value than in 2018 and later. So this is great. The color mismatch is improving. Versus duration, there is no correlation, however. These are some extreme examples of color mismatch. This is a checkerboard. I'm not sure if you can see it on the stream, but it shows, like you can see the checkerboard, which means that the color or the lighting is slightly different between the views. This is the color difference. It is more easily visible. So you can see there are a lot of non-gray areas here, which means that on this frame, the views are quite different in color. And once again, these are really popular videos. So upwards above 7 million views or above 400,000 views. So even those videos have severe artifacts like this. Next, I have sharpness mismatch. Now, this chart is a little different. On the x-axis, we have all videos, and they are sorted by percentage of scenes with sharpness mismatch from the best ones, which have none, to the worst ones, which almost all scenes of which have sharpness mismatch. And overall, the situation is actually pretty good here, but still, there is a number of videos, a significant percentage of scenes of which have bad sharpness mismatch. Next, the chart against the view count. Once again, similar trends as we saw earlier. With the more popular videos are a little worse on sharpness mismatch actually. Against the release date, this is another metric that improved, thankfully. So since 2017 to 2019, we have seen a steady decrease of sharpness mismatch on average on the videos. Against duration, there is no correlation, however. So even the long videos have about the same sharpness mismatch on average as the shorter ones. This is an example. If you look at the text here and at the hand, you can see that it's blurry compared to the text in the hand of the right view here. And the same can be said about the foliage on the left and the right view here. So this is blurry and this is very sharp compared to it. Next, our channel mismatch metric actually found a few wrong depth artifacts. So on these videos, these are VR180 videos with overlays. However, if you pay close attention, you can see that the overlaid content that should be in front of the whole video does not actually move between the views. So it's positioned at infinity, even though it's in front of the view. And here's an anaglyph. You can see that the text is gray here, so it doesn't move. So our channel mismatch metric caught these wrong depth examples on the videos. And in conclusion, I'd like to say that most videos from what we found contain at least one severe distortion, and the quality is not really improving over time for most of the metrics or with popularity. So even the most popular videos from 2019 will have about the same number of artifacts as not very popular videos from 2017, which means that there are no quality control and correction tools, unfortunately. And actually, YouTube could potentially help here by implementing some automatic correction tools. So they have video stabilization for handheld video, and if they could use similar methods to correct, for example, vertical parallax and maybe some other of these artifacts. And of course, short video duration helps. People don't have much time to feel sick, but some sensitive people will still experience discomfort, unfortunately. And we hope to attract attention to this issue. We hope that YouTube will YouTube will implement quality checking and maybe even correction to help boost the VR180 popularity as a very fascinating format. And we will also be releasing the full PDF report on this topic soon. So it will include 400 pages approximately, a lot of charts, a lot of examples, a lot of statistics, and we are planning to release it in the first or second quarter of 2021. And with this, thank you, and I will be glad to answer your questions.